Hello students, good morning to all of you. Today we are going to discuss about another important concept in current electricity. Today topic is electric cell. Electric cell. This is the part 8. Up to part 7 I have given very important concept based on resistors only. Now we are entering into new concept, that is the cells. Right, cells. What is the meaning of cell? What is the meaning of battery? What is the meaning of EMF? Okay, EMF. Next one, terminal potential difference and internal resistance. External resistance we know, but new word is, what is that? Internal resistance. Okay, next, charging of cell, discharging of cell, charging of cell, charging. Okay, charging of cell, what is the formula? Discharging of cell, what is the formula? What is the terminal potential difference? Yes or no? So again, what is the relation between terminal potential difference as well as EMF? Very important formula this is. Okay, V is equal to E minus I into small r. This is a very important formula. Right, this formula if you remember me, so based on that problems are very easy. Derivations also. Right, that is the first part. And the second part will come. What is that? The cells are in series combination. The cells are in parallel combination. So this is the cells are in series combination is the 3-mark question. Similarly, cells are in parallel combination is the 5-mark gunshot question. Okay, so we are having gunshot questions are, which one is? First one is Wheatstone bridge. Next I will give you cells after. So next one is, today I will give you this session only. What is that? The cells are in parallel combination. Cells are in parallel combination. So Wheatstone bridge. These two questions are very important. And conductivity derivation. So first derivation. Total we are having 3 essay questions as well as one more essay. What is that? Resistors in parallel combination. Resistors are in parallel combination. That's it. Only 4 essay questions are there. Correct? First one is conductivity derivation. Next one is resistors are parallel combination. Cells are in parallel combination as well as Wheatstone bridge. These 4 questions are essay questions. Right? Resistors series combination and cells are in series combination is the series. Is the 3-mark question. 3-mark questions. Okay, drift velocity derivation as well as relation between drift velocity and current, drift velocity and current density. These are all 3-mark question. Right. Okay. Now topic is electric cell. What is the meaning of electric cell? What is the meaning of electric cell? Electric cell is the device which maintain constant potential difference, which can maintain constant potential difference between two terminals. We are familiar with the cell, correct? So from class 10th onwards we are learning what is the cell, what is the battery. Battery is nothing but the group of cells. The group of cells is known as battery, correct? The number of cells are combined together, that is nothing but battery. But cell mean only one cell, single, positive terminal and negative terminal. Between positive and negative terminal the potential difference is maintained constant, that is nothing but cell. As well as cell is the device which converts chemical energy or mechanical energy into electric energy. Electric energy, correct? So that is the meaning of cell. Is the meaning of cell, right? So which is the device which converts electrical energy into chemical energy into mechanical, what is that? Chemical energy into electrical energy. That is the electric cell. Electric cell, right? It can drives the charge from positive terminal to negative terminal. It can drives the charge from positive terminal to negative terminal. That is the work done. Potential, correct? So potential, to bring the charge from positive terminal to negative terminal, one point to another point, right? That is the potential. And also as well as, so which are having 2 types. Cells are in 2 types. One is primary cell and the second one is a secondary cell. These are now we are familiar, that's why one more time. So what is that? There are 2 types. One is primary cell and the second one is secondary cell. Primary cell is nothing but, in the primary cell it is do not possible to recharge. Do not possible to recharge. Okay, only direct process only. Direct process. Reversibility, reverse process is not possible. Only one direction. Reversibility is not possible. Such type of cells are known as primary cells. That means these are the device. It can convert chemical energy into electrical energy, but the recharge is not possible. That is known as what is that? Primary cell. So examples are, what is the Leclanche cell, Daniel cell, yes, a dry cell, right, etc. These are all example for primary cells. Similarly, secondary cells are there. Secondary cells mean these are the cells only, devices only, as well as recharge is possible. Recharge, okay, recharge is possible. Very clear? So that is the charging is not possible, but this is the charging is possible, recharged. Charging is possible. Such a type of cells are known as secondary cells. Secondary cells. Examples are, we will say, neon iron accumulator and lead accumulator. Neon iron accumulate and lead accumulate. These are the example for, so many will be there. These are the example for, what is that? Secondary cell. This is small information about cell. Cell is the device. Once you can see, what is that? Electrical cell is the device which constant potential difference is maintained between the two conductors, mean two terminals, either by chemical reaction or mechanical reaction. Either by chemical reaction or mechanical reaction. Again, one more time. What is that? So, inside an electric cell, either chemical energy or mechanical energy is converted into electrical energy, which is used to maintain constant potential difference between the terminals, which is used to maintain constant potential difference between the terminals, is known as cell. And also one more point. What is that? When connected in circuit an electric cell, drives, this one is most important, drives charges in external circuit. Charges in external circuit constituting electric current. General point only. What is that? So here battery will be there, cell or battery. So it is the external resistor will be there. For example, the charges is moving from positive terminal to negative terminal. The flow of charge is nothing but current, electricity. Correct? That is the meaning of this one. What is that? Charges in external circuit constituting electric current. Right. Next point. What is that? Hence, electric cell is the source of electric current. Electric cell is the source of electric current in circuit. It also called battery. Alright, one more point. What is that? The ability of an electric cell. To drive charges in a circuit. Is called EMF. Electromotive force. Okay, electromotive. Later also I will give this one. So this is a very, very important electromotive force. The general meaning, what is that? It is the ability of an electric cell. To drive the charges in circuit. That ability is known as EMF. Electric cell to drive the charges in a circuit. Right? So this is this point. Next one. There are two types. One is primary cell, second one is secondary cell. Primary cell means the charging is not possible. Charging is not possible. Such type of cells are known as primary cells. And secondary cells mean so charging is possible. Charging is possible. This is the so charging should be takes place. Okay, such type of cells are called secondary cells. For this purpose example, primary cell purpose examples are electrolyte cell, Daniel cell, etc. This one is neon iron accumulator and lead accumulator. These are the example for primary as well as secondary cells. Right. Okay, next. Right. So next topic is electromotive force of a cell. Electromotive force of a cell. What is the meaning of EMF? Very important question this one. Electromotive force. Electromotive force mean the potential difference between the electrodes. The potential difference between the electrodes of a cell when it is in open circuit. When it is in open circuit. The potential difference between electrodes. For example, here I have one of a electrolyte. Cell is nothing but it is the device. It can convert chemical energy into electrical energy. Correct? Only this is the chemical substance. Electrolyte will be there. Electrolyte. In that case, what happened? All positive charges will comes together. All negative charges will comes together. Yes or no? So here that is a potential. What is that? EMF also. One more definition. What is that? The work done in carrying a unit to positive charge through complete circuit, including the charge flow inside the cell. Inside the cell, the work done in carrying a unit to positive charge. Unit to positive charge. Correct? So the is a work done. What is that? To separate, that means here bring the unit positive charge together here. This is the unit to positive charge. That means all positive charges will comes here. So this is the positive electrode and all negative electrons, mean negative charges, will go here. That is the negative electrode. So negative electrode and positive electrode connected like that only. Correct? So what is that? The amount of work done. The work done carrying a unit positive charge through complete circuit. Mean all positive charges will come this side. So which is becomes so positive electrode. And this is the becomes negative electrode. Negative electrode. That one also will say EMF of a cell. EMF of a cell. Now the potential difference between electrodes, positive electrode and negative electrode. This is negative electrode. This is a negative electrode. This is the positive electrode. The potential difference between positive and negative electrode inside the cell only. Inside the cell. This is completely so related inside the cell. Inside, that means so this is the first terminal, this is the second terminal. The potential difference between two terminals of the battery when the circuit is open. The circuit is open. Through this direction, current is infinite. So the resistance will be there, no? Current is zero. Current cannot flow. Resistance will be there, no? That is why. Correct? So circuit is open. Open means the current cannot flow. So what would be happen here? So the potential difference between this terminal and this terminal, positive electrode and negative electrode, between difference, potential difference is known as EMF. Is known as EMF. If I close this one, that is not EMF. That is called terminal potential difference. That is a terminal potential difference. The potential difference between two terminals, the potential difference between two terminals when the circuit is closed. When the circuit is closed, that is nothing but terminal potential difference. That is the letter I will give you. Right now I am speaking about EMF only. EMF means, so the potential difference between the electrodes of a cell. Electrodes of a cell when it is in open circuit. That word is very very important. Open circuit. The circuit is open. Is known as EMF. One more definition. What is that? The work done in carrying a unit positive charge through complete circuit. Mean here only. This one. Complete circuit. Including the charge flow inside the cell. Mean unit positive charge you can bring from here to here. In that case, this electrode is becomes positive. A negative charge this side will go. This electrode is becomes negative. Now the potential difference between positive electrode and negative electrode in the cell when the circuit is open is known as EMF. Are you clear? So now, for example, this is the positive ions. Positive ions is moving in this direction. In this direction, moving the amount of work done. Why work done is required? So directly will go no. Like that will come. Doubt will come. But here, why work is required mean these electrolyte also having some opposing nature. Some opposing nature. Correct? Which is oppose the flow of charge. Which is oppose the flow of charge inside the cell. Inside the cell also this electrolyte is having some opposing nature. That opposing nature is nothing but internal resistance. Internal resistance. Remember, this internal resistance is happened because of electrolyte. That means electrolyte is having this internal resistance. The charge is flowing from one place to another place. That means towards the electrodes. Towards the electrode. In that case, this electrolyte is can oppose. That is known as internal resistance. Remember, each and every cell is having some small quantity only, some internal resistance. Each and every cell which is having internal resistance. That's why we can represent it as cell symbol. This is the positive electrode. This is the negative electrode. So now, which is having some internal resistance. Like that we can represent it as a cell. Cell we can represent like this is the positive electrode. This is the negative electrode. This electrolyte is having some internal resistance. We can represent it as small r. Small r. Are you clear? So next I will internal resistance. Internal resistance. EMF. The potential difference between two electrodes inside the cell is known as, that means the circuit is open. The circuit is open is known as EMF, which is represented as epsilon or E. Epsilon or E. Okay. Epsilon or E. And also SI unit is, this is the joule per, what is that? Volt only. What is that? Volt. SI is what? Volt. Right? V is equal to W by Q only, right? Formula. What is that? Joule by Coulomb only. Here also same formula. What is that? E is equal to W by Q. So that Joule by Coulomb is nothing but volt. Joule by Coulomb is nothing but volt. The amount of work done required to bring the positive charge. Positive charge from one point to another point. Unit positive charge through a complete circuit is known as EMF. Alright, still some more points about EMF. What is that? EMF of a cell depends on nature of the electrolyte. Nature of the electrolyte and metal of the electrodes. Metal of the electrodes. Electrodes is and all in the chemistry we learn already. Yes or no? We want to keep the electrodes Correct? This and all chemistry we learn already. So that's what I did not give in so much of explanation. Already chemistry we know. Correct? Direct I have given electrodes, positive electrode, negative electrodes. Right? So metal of the electrodes and temperature of the electrolyte. These are the factors. What are the factors of EMF of a cell? It is depends on nature of the electrolyte and metal of the electrodes, and temperature of the electrolyte. This is the very important basic. What is that? Factors. Next, second point. It does not depends on the size of the cell, that is area of a plate and distance between the plate. It is the independent of area of the plate and distance between the plates. Alright? Okay. Next, EMF is the native force. Electromotive force like that will be the name, but this is the native force. But it is work done to drive the charges in circuit, hence EMF is a scalar quantity. Native force, right? Force means vector quantity. Work only, na? It is a work done. Work done is nothing but scalar only. It is the scalar. So same volt. Next, that is the EMF of cell over. Next, small information about internal resistance. Internal resistance is nothing but the opposition offered by the electrolyte and electrodes. This opposition offered by electrolyte and electrodes of a cell to the flow of current through it. Okay, the flow of charge means electric current only, right? The charges is flowing inside the cell, which is opposed by electrolyte and electrodes. Electrolytes and electrodes. That is nothing but that is the internal resistance. Are you clear? The opposition offered by the electrolyte and electrodes of a cell to the flow of current through it is known as internal resistance, which is represented as small r. SN is what? General only. What is that? Ohm only. SN is what? Ohm. And what are the nature of internal resistance? What are the factors? What are the factors of internal resistance? Now we will see. Right. So factors of internal resistance. Internal resistance depends on, first one is, what is that? Nature of the electrolyte. And second one is concentration of the electrolyte. And the distance between the two electrodes. The distance is more, mean the resistance also more, obviously. Correct? Next one, the area and size of the plates. Plates mean here conductors. What is that? Electrodes. These electrodes area of cross section is more, mean internal resistance should be decreases. Okay. Next, fifth point is temperature of the electrolyte. It depends on temperature of the electrolyte. So what is the relation? Is the temperature and internal resistance. Remember here, it is mean internal resistance increases by decreasing temperature. Which one? Internal resistance. Internal resistance increases by decreasing temperature. So complete opposite. Correct? In the resistors of resistance, external resistance is directly proportional to the rise in temperature. Yes or no? But here reverse. What is that? So internal resistance is inversely proportional to the, that means decreases. It is the increases by decreasing temperature. Temperature can decrease, mean internal resistance should be increases. Right? This is a chemical reaction only. So inside the chemical reaction like that should be takes place. And also remember one more point also here I given potentiometer. Potentiometer is the device. This is the last topic. Later I will explain, but just a small information. What is that? Potentiometer is the device which is used to measure the internal resistance purpose only. Right? So exact value, accurate value of internal resistance. Do you want to mean? We want to use a potentiometer. Potentiometer is the device which is used to measure the internal resistance of a cell. Internal resistance of a cell. Right? Okay, that is a small information about internal resistance. Is the fact it depends on nature of the electrolyte. Different electrolytes are having different internal resistance and concentration of electrolyte, concentration, dope. That means, so what is that? Concentration only, right? Right, that is just power, the power of electrolyte. Correct? Then, so different electrolytes are having different internal resistance. Right, this and all. Next, very important concept, this one. What is the terminal voltage? Previous also I have given EMF. Now, terminal voltage. Terminal voltage means the potential difference between two electrodes. The potential difference between two electrodes, terminals, is the positive terminal. This is the negative terminal. Positive terminal and negative terminal. The terminals, these are the terminals. The potential difference between two terminals when the switch is closed. The circuit is closed. The circuit is closed. That potential difference of two terminals is known as terminal voltage. Terminal voltage. If I give you here is the A and B. The potential difference between A and B when the circuit is closed. When the circuit is closed, the potential difference between two electrodes is known as terminal voltage. The potential difference between the electrodes of a cell. Electrodes of a cell in a closed circuit. In a closed circuit. That is why here the potential difference at potential A is VA, at potential B, VB. The difference mean VA minus VB is nothing but terminal potential difference, which is represented as V. V is nothing but VA minus VB. The potential difference between A terminal and B terminal. A terminal, positive terminal and negative terminal. This is the positive electrode. This is the negative electrode. Negative electrode. Alright. At the same time, one small 3-mark question. What is that? What is the relation between E and V? You can write first clearly definition of EMF. E mean here EMF. V mean terminal potential difference. First point you can write it. What is the definition of EMF? Alright. Next, the second point is what is the definition of terminal potential. Terminal potential. After that, so this step, third step. What is that? When the switch is closed. When the switch is closed, then what would be happen? The current is flowing in this direction, right? The current is flowing in this direction. That current is equal to how much? The flow of current is equal to how much? The flow of current through what is that? External resistance. Here inside one resistor will be there. That is internal resistance. That is the internal resistance is R. Okay, na? That is we will give you in this manner. This is the positive terminal, this is the negative terminal, and this is the internal resistance. Internal resistance is the related to two, so cell only. Inside the cell, electrolyte is having internal resistance. That is right. Okay. So when the switch is closed, now current is flowing in this direction. In this direction. Correct? This is the direction of flow of current. So now resistors. First resistor and second resistor. These two resistors, which combination? Series combination. The flow of current is I. Right. Then the total current is equal to how much? So same formula. What is that? So V is equal to I, general formula, you know, right? General formula. So now here V we will consider as a EMF is equal to, this is the I, and total resistance, how much will be there? R plus R. R plus R. Series combination only. So this is external resistance, this is the internal resistance. external resistance and internal resistance. Therefore, so V is equal to IR, mean E is equal to I into R plus R. So now I want to I direct formula. This is, what is that? So I is equal to V by R, like that one. Here V is nothing but we will consider as a EMF. So E is E by R plus R. Now I want to E is equal to, transfer this side. E is equal to I into R plus I into small r. This is the formula. Very, very, very important formula. This is the relation between EMF and terminal potential difference. Where E is equal to EMF, where V is equal to terminal potential difference plus current and internal resistance. When the switch is open, in that case, what would be happen? The flow of current in this direction is 0. So that this is becomes 0. Then E is equal to, becomes V. V is equal to E. E is equal to V. Right? So, or else is the I is equal to 0, means this is the becomes 0. E is equal to I into small r. Right? Okay. So that is not required right now. So now you can observe there. What is the formula? E is equal to V plus I into R. This is the EMF and terminal potential difference formula. As well as I want to terminal potential difference. Therefore, V is equal to, this one transfer that side. Therefore, E minus I into R. V is equal to E minus I into R is the very, very important formula, terminal potential difference. This formula only we have to use to find the effective EMF in the series combination of cells and effective EMF, effective current or effective equivalent EMF in the series combination as well as parallel. That means cells are in series combination, cells are in parallel combination. In that case, we have to use this formula. Right? V is equal to E minus IR. What is the meaning of V? Terminal potential difference. Right? Okay, next. Right. So, next, different concepts with a cell. First one is discharging of a cell. We will represent a discharging cell like that only. So what is the discharging cell mean here? This is the positive electrode, this is a negative electrode. So now the current is flow from anode to cathode outside the cell. What is the outside cell direction? Anode to cathode. Internal is reverse. Okay. So like that only. So positive to negative. This is the discharging cell. That means current is leave from the cell. Like that only. Leave from the cell. That is a discharging cell. Symbol like that we will use. Very, very, very important discharging symbol. Okay, discharging symbol cell. Discharging of a cell symbol. Okay. So now terminal potential difference here we will represent it as V is equal to E minus IR. What is it? V is equal to E minus IR. In that case, the terminal potential difference is less than of EMF. This is the cell internal resistance. This is inside a cell only. So formula V is equal to E minus I into R, small r. So V is less than of E. Okay. Next, charging of a cell. We will give it to the charge. Charging of a cell. We can represent it as current like that one. It is the entering to the cell. The current is entered into the cell symbol. Remember here, this is the current is entered into the cell. This is the leave from the cell, like that will be there. Is the entered into the cell. So that what would be happen here? V is equal to E plus I into R will come. That means terminal potential difference is greater than of EMF. Is greater than of EMF of a cell in this situation. Okay, charging situation. This is the discharging situation. Right. Next one. Open circuit and short circuit. What is the meaning of open circuit? Open circuit means the what is that? The circuit is open. The circuit is open. Correct or not? See that. What is that? If the cell is connected, to infinite external resistance. If the cell is connected, infinite external resistance or the terminals are left open. When we will say open circuit, infinite resistance. Previous also I have given infinite resistance like that only. Correct? Infinite resistance. That's what we took the infinite resistance. The open circuit resistance is infinity. Okay, infinity. The circuit is infinity. The resistance is infinity. For example, I will give you one more diagram also here. For example, here, so circuit like that will be there. Okay, this is the A and this is the one more circuit, and here one more circuit. Resistor will be there. This is the B. Now here like that will be there. That is the open. That is the open. So this is the open symbol, that is. So now in this direction the resistance is infinity. Therefore we can neglect this one. We can neglect. That is the open. It's a open circuit, right? That is the open terminal only. Therefore that's what here the resistance is equal to infinity. No need to consider. Remember, very very important for problem purpose this is. So many circuits like that will be there. Like that will come in the exam problems point of view. Right, open circuit. The terminal is open. The terminal is open like that only. So in that case, so the resistance is infinity. The resistance is infinity. Remember, so like that symbol is there mean that is the not a open. That like that symbol is there mean that is the not a open. That is the closed circuit only. Like that is the meaning. Okay. So here also, if I give here symbol like that mean that is the not a open. That is the closed only. Right? So like that symbol is there mean that is the closed. The symbol is not there mean that is the open. In that case, we can neglect that resistance of value. The resistance of given resistor value. Right? Okay. So then the circuit is said to be open circuit. So R is equal to infinity. R is equal to infinity. So through this direction current we will consider as a 0. The current consider as a 0. Therefore, what would be happen? V is equal to E minus IR only. Na? So here I is equal to 0 mean what happened formula? V is equal to E will come. V is equal to E. And also remember this point, open circuit resistance is infinity. Open circuit resistance is infinity. Right. Okay, next. Short circuit. Short circuit also previous also I have given. Yes or no? So for solving problem purpose, I use this word short circuit. So short circuit is nothing but if the ends of a cell, are directly, cell are directly connected with a conducting wire. That conducting wire resistance is equal to 0. Remember, that conducting wire resistance is equal to 0. Then the cell is said to be short circuit. Okay, na? The cell is said to be short circuit. So for example, I will give you one question, one diagram here. So short circuit related diagram. So in this manner, what is that? For example, here cell will be there. This is the cell. Okay. So now here resistors are there. Here one resistor, here one resistor, here resistor will be there in this manner. So now current is flowing in this direction. Okay, so now this is the R1 resistance, this is the R2 resistance, this is the R3 resistance. So now both are series combination, therefore obviously what happened, potential is different will be there. In series combination current should be decreases. Current should be decreases. Correct? Why? Because here some opposing, here are some opposing, here are some opposing will be there. Therefore current is decreases. Now I want to maximum current in the circuit. I want to maximum current in the circuit. In that case, I can connect with one of a conducting wire. Is a conducting wire from A to B. If this wire do not have any resistance, resistance of this wire is equal to 0. In that time we will say the circuit is short circuited circuit. Okay, now what is that? The cell is said to be short circuit. So directly connected with the help of one conducting wire. This is nothing but short circuit. In that case, what happened? The current is maximum. Alright, and also remember this point, short circuit current of a cell is a maximum while V is equal to 0. Okay, while V is equal to 0, that means, so terminal potential is equal to 0. Conducting wire, this is short circuit time, what is that? V is equal, terminal potential is equal to 0. Therefore formula, you know what is that? E is equal to V plus I into R only, na? V is equal to 0 means E is equal to I into R. So I is equal to what is that? E by R. Small. Internal resistance is a very small value. That's why what happened here? I is equal to maximum. Right? V is equal to, what is the formula? V is equal to IR. The resistance is equal to maximum. But here internal resistance value is very small, just 1.5. Okay, 2 like that only will be there. That is the internal resistance. Are you clear? So this is the small concept. What is the cell? What is the EMF? What is the internal resistance? What is the terminal potential difference? Okay, so what are the discharging cell? And what is the charging cell? And what is the open circuit? What is the short circuit? Right? So now we will see another concept. Right. So now very important law, that is Kirchhoff Law. Okay. So now new concept is the Kirchhoff's laws. Why Kirchhoff laws enter into our topic? Right? Why? What is the use of Kirchhoff laws? What is the importance of Kirchhoff laws? How many laws are there? Okay. How can we use Kirchhoff laws? How can we apply Kirchhoff voltage law? Okay, these and all questions are there. So for what purpose Kirchhoff law is important, sir? Because, so already we know some, what is that potential difference between A and B. Correct? Internal resistance is equal to how much? Current is equal to how much? Correct? These and all we have to find with the help of Ohm's law. V is equal to I into R. But that Ohm's law is only suitable for some simple circuit purpose only. But some complicated circuits are there. In that case, Ohm's law is not suitable. For that purpose only, Kirchhoff is introduced two laws. Okay, that is the Kirchhoff First Law and Second Law. What is the Kirchhoff First Law? For Kirchhoff First Law, we can call it, that is the Junction Law or Junction Rule, Current Law. Okay, next Second Law we can call it, that is a Loop Rule. Is the Junction Rule. This is the Loop Rule or Voltage Law. Alright, we will see now Kirchhoff First Law as well as Second Law. Previous also I have given. So now also again one more time we will revise. What is that? Kirchhoff First Law or Junction Rule or Kirchhoff's Current Law. This is, we can write it KCL. Kirchhoff Current Law. KCL. Alright, junction. What is the meaning of junction? Junction, remember here, junction is nothing but three or more conducting wires meet at a point is known as junction. What is it? Three or more, not a two. For example, two wires conducting point, we can call it, that is the node only. What is that? Node. This is the node. Two conducting wire meet at a point, we will give you node, and this is the one wire, this is another wire, this is the another wire. Three wires are, three conductors are there. The three conductors what is that? Meet at a point. This point is known as a junction. This one also junction, but this one, this one, this one, and this one not a junction. So this is the node only, not a junction. Junction is the X and Y. Alright, so junction. The entering current to the junction is equal to leave current from that junction. How much current is entered to the junction, that much current completely leave from that junction. Therefore, at the junction, the total current is equal to 0. Correct? Entering current is equal to leaving current. The total current is going, entered and going. So that at that junction, the current is equal to 0. Right. So what is the first law? At any junction, remember, very important, one more question for this definition. At any junction, the sum of the currents entering the junction. At any junction, the sum of the currents entering the junction is equal to the sum of currents leave the junction, leave from the junction. So this is entering current I1, I2, I3 entering to the junction. This is junction. Three wires are there. Correct? So next here. So this one and this one, this one. This is the leaving current. Leaving current from the junction. Sum of entering current. What is that? I1 plus I2 plus I3 is equal to sum of leave the junction. Currents leave from the junction. This is the I4, I5, I6 is the leaving current. This is the entering current. So that sum of I1 plus I2 plus I3 is equal to sum of I4 plus I5 plus I6. Or else I1 plus I2 plus I3 plus minus I4 minus I5 minus I6 is equal to 0. Why? Because entering current is equal to leaving current. Both are equal. They are equal and opposite. Therefore 0. Correct? So this is the junction rule. Right. One example also I have given once, you can observe there. So this is the 3 ampere. This is the 4 amperes. And leaving current, this is the 2 amperes. And leaving current I is equal to how much? According to Kirchhoff current law, what is entering current? Sum of entering current is equal to sum of leaving current. Therefore, I want. So I is equal to, this is the 7 only, 7 minus 2 is equal to 5 amperes. This is the, so this junction, this wire, this conducting wire through this direction, how much current is flowing? This junction in this direction, current is equal to 5 amperes. Entering current is equal to leaving current from the junction. So this is the, what is that? Kirchhoff's first law, and also which is having some significance. What is the significance? What is the significance of first law? Very important, one mark for this one also. What is the significance of first law? So first law significance is, so entering charge to the junction, leaving from the junction. That means the total charge is conserved. Why? Because entering charge is equal to leaving charge only. How much charge is entered into the junction, that much charge is leave from the junction. Therefore, there is a charge is conserved. Their charge is conserved. That's why here. So, significance of first law is law of conservation of charge. Law of conservation of charge is the significance of first law. First law significance is what? Law of conservation of charge. Why? Because entering charge is equal to leaving charge. This is the Kirchhoff first law. Right. Next one, Kirchhoff second law. Kirchhoff second law is very important. Kirchhoff second law. What is Kirchhoff second law? Kirchhoff second law, we can write it. What is that? So Kirchhoff second law, loop rule, as well as Kirchhoff's voltage law. Kirchhoff voltage law. KVL. KVL means Kirchhoff voltage law. Kirchhoff voltage. What is the Kirchhoff voltage law? So the algebraic sum of charges, algebraic sum of charges in potential, algebraic sum of charges in potential around any closed loop, around any closed loop involving resistors and cells in the loop is 0. In the loop is 0. The algebraic sum of charges. Okay, charges. Extremely sorry, ma, this point is missed out here. Not a charges, changes. Extremely sorry, Nana. So what is that? Algebraic sum of changes in potential. Changes in potential, delta V. Okay, changes in potential. Algebraic sum of changes in potential around any closed loop, around any closed loop involving resistors and cells in the loop is 0. In the loop is 0. The summation of delta V is equal to 0. In the closed loop, remember this word also very, very important. What is that? Closed loop is applicable for only closed loop. Closed loop, the algebraic sum of the changes in potential, changes in potential around any closed loop involving resistors and cells is the loop is 0. Is the loop is 0. Right? It is what is the significance of second law? What is the significance of second law? Here, so what is that significance? We can write it here. Okay. So significance is law of conservation of energy. What is the law of conservation of energy? Law of conservation of energy is the significance of second law. Why? Because entering energy, right here, energy is conserved. Therefore, law of conservation of energy. This is the second law of Kirchhoff. Kirchhoff second law. Kirchhoff second law. Right. So what is that? Voltage law. Kirchhoff voltage law. What I given? The algebraic sum of potential is equal to 0. The change of algebraic, the change of potential is equal to 0. Correct? How is the potential 0? How is the potential is equal to 0? Right. Once you can observe my here. So this is the, I will consider starting point only. At this point, potential is equal to VA. At this point, potential is equal to VA. So compulsory we want to consider as a closed loop only. Remember everybody, very, very important. This one now is a closed loop. Now the current is flowing in this direction, again came here. This is the initial position, this one only. Final position also, this one only. Then the potential difference at this point is equal to how much? At this point, the change in potential is equal to how much? At this point, the change in potential is equal to how much? So, initial potential is equal to how much? VA minus final potential also VA is equal to 0. Correct? Is equal to 0. Initial potential as well as final potential both are 0. Therefore, the net potential is equal to 0. The change in potential in the closed loop is equal to 0. The significance is energy only, law of conservation of energy. Why? Because you know V is equal to W by Q only. Na? W by Q, W net by external work done by charge is equal to this is 0 mean work done also 0. No? W is equal to 0. W is equal to 0. This is change in potential. Change in potential. That means here, so the total energy is conserved. The total energy is conserved. That's why significance is, the significance of Kirchhoff voltage law is law of conservation of energy. Law of conservation of energy. Okay. At this point, what is that? The change in potential in the closed loop. The change in potential in the closed loop is equal to 0. Why? Because at point A, initial potential as well as final potential is both are same only. Therefore, it depends on only initial and final position. Initial and final position. Potential energy also same, right? Potential is depends on initial and final position only. Same like that. This one also. So initial and final position is equal to 0. That is the second law. Right. So very important this one. What is that? How to apply Kirchhoff voltage law. How to apply Kirchhoff voltage law. So first point is closed path can have two directions. First one is closed path. We want to draw closed path like that one. This is a closed path which is having two directions, any directions, either clockwise or anti-clockwise. Here only one loop will be there. Therefore, I have written only clockwise or else anti-clockwise also no problem. Anti-clockwise also no problem. This is a closed loop. Any one direction, either clockwise or anti-clockwise. That is the first point. Second point is very important. This is the potential gain and potential drop. When the potential is gained, when the potential is dropped. Right, first point, see that. What is that? If path goes from higher potential to lower potential, higher potential to lower potential, higher potential to lower potential, in that case, the potential is drop. We will say potential is drop. That means delta V is equal to negative. Drop means change in potential is negative. When the delta V is negative, the current, the path, we are selecting the path goes from higher potential to lower potential. Once again observe, this is the path. This is our selecting path. We want to select the closed path. So closed path in this direction, in this direction, in this direction, in this direction. This is the closed path. Is a move from where to where? Higher potential to lower potential. Higher potential to lower potential. In that case, the potential drop we will consider as a negative. Potential drop consider as a negative. Right? Second point. What is the second point? So, if path goes from lower potential to higher potential, the path goes from lower potential to higher potential, lower to higher potential. In that case, potential is a gain. Potential is gain. So, delta V is equal to positive. Delta V is equal to positive. Right? We are selecting path is the most important here. Path. The path is moved from higher to lower, potential drop, and lower to higher, so positive. This is the drop, this is the gain. This is the delta negative, is the positive. This is the positive. So how can we apply for cell? So cell, once you can observe. So this is so positive terminal mean higher potential, negative terminal mean lower potential. This is the positive, this is the negative, this is the higher potential, this is the lower potential. Now my selecting path, my path, closed path, I don't know closed path, where to where? In this direction will be there. In this direction mean where to where? Higher to lower, higher to lower, in this way. The current is flow, my path is moving from where to where? Higher to lower. Path is moving from higher to lower. In that case, this potential I will consider negative. This potential, for example, 2 volt will be there. Now I will consider minus 2 volt. Minus 2 volt in the circuit. Example I will give you. Wait. Okay. So this is. Next term. My path is opposite will be there. That means lower to higher. The path goes from negative to positive. Negative to positive. That means lower to higher in this direction. Okay. My direction is this path. In that case, delta V is positive. That means, for example, here 3 volt will be there. This value is becomes 3 volt. Positive 3 volt. This value is negative 3 volt. This value is positive 3 volt. That is the for cell purpose. Next, for resistor purpose. For resistor purpose. Now resistor, the current is flowing in this direction. This is the higher potential. This is the lower potential only. So now this is the resistor. This is the R resistor will be there. Now my direction is along the direction of current. Along the direction of current, like that will be there. My current also moving like that only. My path direction also same like that will be there. In that case, delta V is negative. Delta V is negative. Okay, delta V is negative. Are you clear? Delta V mean I into R. I into R is equal to V only, na? That means this value is becomes negative. IR value is negative. For example, so this is the I, this is the R. I into R is equal to V only, right? So this value becomes negative only. Okay, delta V is equal to negative. Delta V is equal to delta V now here I into R. I into R is equal to negative. Similarly, in this case, so this is the direction of current and this is the my path. This is the my path. In that case, I into R we will consider as a negative. We will consider as a positive. Sorry. We will consider as a positive. These rules are very, very, very important. Right. Now I will give two examples. Right. So one example problem I have given. Once you can observe there. So what is that? So this is the loop circuit like that is given. So this is the 10 volt potential, 10 volt battery. Okay, na? So now this is the current is going like that only. This is the 2 ohms resistor. This is the 3 ohm. This is the I will consider R1. This is I will consider R2. R1 and R2. Okay, everything is fine. Like that I have given diagram. Once you can observe. So I can remove first this and all. Right. Okay. So like that the diagram is given. So now first we want to select. This is the lower potential. This is the higher potential. Correct? Lower potential and higher potential. This is the H. This is the L. Lower potential, higher potential. Now this is 10 volt. Now current is going like that only. This is the direction of current. Always move from higher potential, lower potential. Right? Current is moving like that only. Na? Right. Now we want to select. What is that? So loop. Loop you can say any path. What is that? In the closed anti-clockwise also no problem. Closed path also no. What is that? Clockwise also no problem. Anti-clockwise also no problem. Clockwise also no problem. Now I will consider so clockwise direction. Okay, na? Clockwise direction. In this direction I will consider. So this is the direction of loop. Path. Direction of path. Direction of path is going where to where? So you can observe there. Lower to higher. Correct? Lower to higher only, right? So this is the path is going like that only. What is that? Where to where? So lower to higher. Lower to higher. Correct? You can observe once. Lower to higher. If I take in this manner, mean higher to lower. That's it. Higher to lower. Now condition is where to where? Lower to higher. So lower to higher, minus to positive, minus to positive. Correct? Therefore potential is positive or negative here. Lower to higher, potential is positive. That means here 10 will be there. So that I will consider plus 10. So plus 10. The change of potential is equal to 0. Now loop I will give you A, B, C, D, A. A, B, C, D is a closed loop. So now summation of delta V is equal to 0. Summation delta V is equal to 0. Correct? Right. So now this potential lower to higher. Lower to higher is plus 10 volt. 10 volt. Next current. This is the I and I. So this is the I current. So now direction of current is going like that only. This is the resistor. My direction also same will be there. So current direction through resistor and my path both are in same direction. Which one? So this one only. The current is moving this side. My path also same direction. There is one negative only, right? Negative. So that negative symbol. I into R. I into R value how much? 2 ohms. Next here also both are in same direction mean minus. So that minus I into resistance is equal to 3 ohms. So minus 2I, minus 3I, minus 5I. minus 5I. So now I want to I. Question is find the current in the both resistors. That means in this resistor current is equal to how much? In this resistor current is equal to how much? That is the question. Therefore in both resistors, so 5I is equal to 10, I is equal to 2 amperes. The series combination or direct also. Series generally series combination, this is 2 plus 3 is equal to 5. Is a V is equal to 10 now. Yes or no? R is equal to how much? 5. V is equal to 10. I is equal to how much? V by R. 10 by 5 is equal to 2 amperes. Simple circuit. That's why easy. Right? That is the one method. And another alternative method also will be there. That one also Kirchhoff law. Kirchhoff law we can define like that also. Kirchhoff law we can define in this manner also. Kirchhoff voltage law. What is that? The total EMF. The total EMF is equal to the product of sum of current and resistances. The total EMF is equal to the product of sum of current and resistance in the given circuit. That is the Kirchhoff voltage law. This one also correct answer. What is that? The total EMF is a product of sum of current and resistance in the circuit. Are you clear? So now total EMF given circuit how much? 10. So 10 is equal to product of sum of current and resistance. So first one here, this is the I and this is the R1. So I into R1 plus here I into R2. Product of sum of current and resistance. Okay na? So 10 is equal to I is equal to I only. R1 is equal to 2 into I 2I plus 3 into I 3I is equal to 5I. Is equal to 5I. 5 1 is 5 2. Therefore I is equal to how much? 2 amperes. Right? Most important this one only. So these rules if you remember me, so this is the very easy. Alright. So this is the Kirchhoff voltage law. Right. Next session I will give you cells are in series combination, cells are in parallel combination. So now in that time also I can use these rules. After that I will solve some problems based on that also. Alright. Okay. So thank you to one and all. Thank you.